Welcome back. This is lecture 8 of EC253C Microprocessors and Microcontrollers. We have been discussing about 8085 microprocessor. In last lecture, we have discussed some of the instructions of the instruction set of 8085 microprocessor, and we have also discussed jumps. In last lecture, I told you jumps are of two types: unconditional jumps and conditional jumps. Unconditional jumps, that they jump to a certain location without checking any conditions, but conditional jumps are those jumps which jump only if some conditions are met. We have discussed an unconditional jump, JMP, and we have also seen how it can be used in a program, how certain number of how a group of instructions can be executed repeatedly using an unconditional jump. Here we will, in this lecture, we will discuss about conditional jumps. Conditional jumps, as I told you, conditional jumps are those jumps we jump to a certain location only if some conditions are met. Some condition is met. That means they won't jump always, but sometimes they will jump to that location and sometimes they won't jump. And what will happen? The next intersection in the sequence will get executed. Some conditions are checked. For example, we might have certain instruction in your program: instruction 1, instruction 2, instruction 3, instruction 4, and here we might have a conditional jump. And if that condition is met, it will jump to this instruction. If the condition is not met, the program will follow this will actually execute the next instruction in the sequence in the program. So if the condition is met, if the condition, whatever the condition is, we have not discussed what the conditions are. If the condition is met here, this program will jump to this instruction. That means after executing this instruction which has the conditional jump, it will execute this instruction again, and then this instruction, then this instruction again. Then again the jump will be, the condition will be checked. If the condition is met, it will again jump to this location, and if the condition is not met, this instruction will be executed next. That means depending whether the condition will be met or not, these three instructions will be executed multiple times. In case of unconditional jumps, these instructions would have been executed infinite number of times, but here the number will be finite, and that number will be decided by the condition. Whenever the condition is not met, this instruction will not be executed again, but the next instruction will be executed. So let us discuss what are these conditions which microprocessor checks. These are actually flags in the flag register. We have our flag register. And these conditions are flags in this flag register. What were the flags in the? We had carry flag, which was set whenever there was a carry in the accumulator, and cleared. That means there was a 0 was put in there whenever there was no carry during an arithmetic operation. We had zero flag. Again, this zero flag was set. That means 1 was written in that position whenever accumulator got a 0 during an arithmetic or a logical operation. Similarly, zero flag was cleared whenever there was a non-zero number inside accumulator. Similarly, we had parity flag. We have also discussed this parity flag. And then we had sign flag. We also had auxiliary carry, but auxiliary carry is not checked by 8085 microprocessor for jumps. So only these 4 are checked. and pertaining to each flag we have two jumps, one for if the flag is set, another if the flag is carry. One for when the flag is set, another for when the flag is cleared. For example, for carry flag we have two instructions, JC jump if carry and JNC jump if not carry. What does this instruction mean? Jump if carry, the full syntax will be something like this, JC and there will be an address. Or alternatively, I have told you in the last class, instead of writing the address we can write a label that is actually pointing to some instruction in the program, this label. So the full syntax will be something like this. What does this mean? This means if the carry flag, this instruction means if the carry flag is set, jump to this particular address or label, and if carry flag is set means there is one there. And when will be there one? When the previous arithmetic or logical operation, during the execution of the previous arithmetic or logical operation, there is a carry in the accumulator. And if the carry flag is cleared, that means if carry flag has 0, then don't jump. What to do then? Follow the next instruction. For example, if I have some instructions like this, 1 2 3 4, or maybe I will write a program to explain this. Move immediate accumulator I will write in hexadecimal 23H. Add immediate 56H. So maybe after adding these instructions I have a jump if carry JC to maybe I have given some label to this ABC at immediate C. And this is my program. So what will happen when the first instruction will be executed? A number 23 in hex will be moved to accumulator. That means accumulator will have 0010 0011, and then when the next instruction will be executed, 56, number 56 will be added to the accumulator and the contents will be stored in accumulator. That means accumulator had 23, now 56 will be added. 56 means 0 56. This will be added to the contents of accumulator and the result stored in accumulator. So accumulator will get a new number. That new number will be equal to 1. That new number will be 1 1 1 1 0 1 1 0 1 1 1 0. So the new number is 7, and this is 7 9. So accumulator will have 7 9. Accumulator had 7 9. There was no carry, so that means if there was no carry, that means carry flag inside the flag register will not be set. That still will have 0. So next this instruction will be executed. When this instruction will be executed, it will check the carry flag, jump if carry, but there was no carry, so it won't jump to here, but it will execute the next instructions. after this JC. Alternatively, if I had some other numbers in here, for example, instead of 23 and 56H, maybe I was adding F2 and 27H. So what will happen here? The first accumulator will get F2, that means accumulator has F2. F2 is 11110010, and then number 27 will get added to the contents of accumulator, and the result will be stored in accumulator. Number 27 is 0010 and 7 0111. So upon adding, we will get 1 1110 1110 1110 1110. So we got a carry. When this operation will happen, when this instruction will be executed, since we got a carry, the carry flag inside the flag register will be set, that will get a 1, and accumulator will get what value? Accumulator will get 1 9. And after executing this instruction is executed. This again will check whether the carry flag is set or cleared. Since the carry flag is set, that means the instruction will force processor to jump to this location ABC. That means forcibly in program counter, in fact without jumping, what program counter will have got? Program counter will have got the address of the next instruction. But since it's forcing a jump here, it's forcing processor to go out of sequence, so program counter will have the address of this instruction, and next this instruction will get executed again. That means 27 will be added to this number again, to the number in accumulator 19. This one will be lost, so I will be adding 27 again to this number. We again will get some result. Again it will check if there was carry in the previous instruction or not, and again if there was carry, it will jump to here. If there was not carry, it will execute the next instructions in the program. This program, I showed you this program only to show how carry flags or how some other flags work, to actually just show you. In fact, this program doesn't carry any meaning, it's meaningless, but it just show you how a carry flag will work. For example, similarly, we have another instruction, jump if not carry. That means you have to jump if it's the reverse of jump if carry. Here we have to jump if carry flag is cleared, that means carry flag has 0, and don't jump if carry flag is set, that means carry flag has 1. For example, I may write the same program here, like move immediate 20 or 83H to accumulator, add immediate, move immediate accumulator 83H, add immediate 33H. Okay, then I can write jump if not carry to ABC. Okay, after this maybe I have some more instructions, like I am storing the value of accumulator STA in some memory location, maybe 2000. So what is this program doing? First instruction, this simple one, moving immediate a number 83H into accumulator, that means accumulator will get 10000011. Then I am adding 33, that means adding 000110011. This will give me 110111101 11111, 1 here, 0 here, 1 here, 1 here, 0 here, 1 here, this number, and this number, that means accumulator had 83, Now accumulator will have, this is 8 and 9 10 11, that means B, and this is 6 B6. So now the next instruction will be executed. It will check the carry flag, and it is saying jump if not carry, if the flag is not set. So the flag will not be set because in the previous instruction there was no carry, so it will jump to ABC. That means this instruction will get executed again. 33H will be added to B6, 33H again 0011 0011. So I will be executing this instruction again. I will get 1 1 1 1 0 1 1 1 0 1 here, 1 1 1 0 1 1 1 1 1. Again there was no carry, but accumulator got another new number. Accumulator this time got 8 14. 14 means D, 14 means E, E9. Again this instruction will be executed, and it will check whether the carry flag was set or is 0. Since the carry flag is again 0 because there was no carry here, so it will again jump to ABC. ABC is pointing to this instruction. Again 33 will be added to the contents of accumulator. This time the contents of accumulator are E9, and the result will be stored in accumulator. That means I have to again add 33 to E9. So 1 1 0 1 1 1 1 0 1 1 1 0 1 1 1 0 1. Oh, I got a carry here. When I will get a carry flag will be set. Since now the carry flag is set, when this instruction will be next executed, it will say jump if not carry, but there was a carry, so it won't jump to ABC, but the next instruction will be executed. So whatever is in accumulator will get stored in 2000H. That means accumulator this time had this number. That means accumulator had a 1 8 19 11 AB 1B 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 will be stored in 2000H. Again this program doesn't have it's not that meaningful. It's again I'm showing it to actually demonstrate how jump carry and jump not carry works. Similarly we have other flags like jump 0 and jump not 0, jump if minus for sign flag, and jump if plus and jump if minus. We have jump if parity is even, that means parity bit is not set. Jump if parity is odd, that means parity bit is set. You can check these in your book again, how these instructions, how these flags, how these jumps, conditional jumps work. I may show you another program here. Let's assume that I have to multiple two numbers. Maybe I have to multiple 3 and 5. In some of the microprocessors we have an instruction mul, M-U-L, that simply multiplies 3 and 5. But let's assume we don't have multiplication. How we do it? How we multiply 3 and 5? We do it using repeated addition. What is the repeated addition? You may be aware of that. Repeated addition means that multiplying two numbers, 3 multiplied 5, we can either add 5 number of times, or we can add 5 3 number of times, and it will give us the same result. So let's assume here that we have to multiply these two numbers using repeated addition. So how will be our algo? Let me try to make a flow chart. I will be starting. First I will be loading these two values. Load 3 and 5 in registers, because I have to multiply them. I have to store in some general purpose registers. Okay, then one of these numbers will act as counter. Like I will do something like this. For example, I will add 5 repeatedly. 5 I added once, I will decrement this 3, this will become 2. Then I will add it again, I will decrement this 3, it will become 1, and I will again, and I will decrement this 0, and I will be checking this this register which contain the another register, whether it's reached to 0 or not. If it hasn't reached to 0, I will be continuing adding 5 5 5 5, and when it reaches to 0 I will stop and I will get my result, that is 15. So I will try to do that in my program also. So to make it, to add these numbers, I can add it once, add 3 and 5, or add 5 to accumulator which may contain 0, and number 3 I will act as I will make it as counter, and then I will decrement the other register, decrement 3, and then I will check whether if 3 register 3 the register containing 3 has reached to 0. If it has reached to 0, I will end my program here. If it has not reached to 0, I will again add 5 to accumulator. I hope you have understood this program. I may be loading these values 3 and 5 in two different registers, maybe register B and C, and then I will be adding B may contain 3 and C may contain 5. That means I will be adding register contents of register C to accumulator. Accumulator will have 0. That means 5 will get added to the accumulator, and then I will be decrementing this register, B, decrement register B, and I will checking if register B has reached to 0 or not. And when it has reached to 0, that means I have added 5 thrice. But if it has not reached 0 yet, I will go back to this instruction where I will add contents of register C to accumulator again and again. So let me try to write a program for this. First I will be moving these two numbers in two registers. Move immediate B 05H, move immediate C 03H. I will be putting accumulator, I will be putting a 0 in accumulator. By default it has 0, but I will again save a 0 in here. Then I will add this number, add accumulator C. Temporarily I will save this whatever. So 5 will get to the 5 will be added to the contents of 3 will be added to the contents of accumulator, and the result will be stored in accumulator. And temporarily I will store this result somewhere else. I will do move in some other register, move D accumulator. Okay, then I will decrement register 5, decrement 5. When I will decrement 5, now I have to check whether B has 0 or not, but that I only can check whether the 0 flag is set or not, and 0 flag only gets set upon checking the contents of accumulator. So I will move B, sorry, I will move contents of B to accumulator, and then I will check jump if not 0, jump if not 0, J and Z to ABC. While will this ABC? This ABC will be here. I again have to check the add the contents of C to accumulator. But before that, the previous addition, the previous sum, I have to load that back into accumulator. So I will write an instruction here, move D accumulator. So to jump to ABC, I will name this instruction, label this instruction as ABC, and if I have the final result of, I will store in it in some rest, or we don't, or let's stop here. Let us see what will this program do. I have my register B first, register C, I have also used register D, and then I also have used accumulator A. I hope this program works. I am immediately moving number 5. 5 in hexa and decimal are same, 5, to B, and then I am moving number 3 to C. I am moving to accumulator, I am moving to 0. Sorry, this should be move accumulator D. Whatever is in D should be moved to accumulator, and here I will be putting 0 in register G, 0 in register D, and then when this instruction will be executed, this 0 will get transferred here to accumulator. And in next instruction, C will be added to the contents of accumulator, and the result will be stored in accumulator. That means 3 will be added to 0, and the result is stored in accumulator. So accumulator will get 3. And next instruction, when the next instruction will be executed, move DA. The contents of accumulator will be stored in D. That means D3 will be here. Then I will be decrementing B. So B will get 4. It had 5, it will get 4. Move AB. This 4 I will move here. Jump if not 0. Is 0 flag set? No, 0 flag will not set because I have 4 in my accumulator. 0 flag will be cleared. So it will jump because there jump if not 0. That means 0 flag is not set, it will jump. Where it will jump? It will jump to this location. And this instruction will be executed again. What does this instruction do? The contents of D are transferred to accumulator. That means accumulator will have 3. Move accumulator, and then this instruction will be executed. C is added to the contents of accumulator and result stored in accumulator. That means accumulator will get 6. And after this 6 will be transferred to D temporarily. Register B will be decremented. Register B will get 3. B is transferred to accumulator. Again 0 flag is checked. Still 0 flag will have will not be set because I have a non-zero number in accumulator. Again these instructions will be executed. D will be moved to accumulator. Accumulator will get 6. Number C, register C will be added to the contents of accumulator. That means accumulator will get 9, and then this 9 will be temporarily stored in D. And again register B will be decremented. It will have 2. And again we will have moving this B, contents of register B to accumulator. Accumulator will get 2, and then this and again the 0 flag will be checked. Still the 0 flag will not be set because jump if not 0. So it is not 0. 0 flag is not set because still accumulator has a non-zero number. Again these instructions will be executed. That means whatever was in D will again be moved to accumulator 9, and then the contents of C are added to the accumulator and result stored in accumulator. That means accumulator will get 12. After that this 12 will be temporarily stored in register D when this instruction will be executed. After that B will again be decremented. That means B will get 1, and B will be moved to A accumulator, and then again it will check the condition of the 0 flag. That's still not set. That means it will again jump. It will again jump to this instruction. Again this instruction will be executed. That is the contents of accumulator will be moved. Contents of register D will be moved to accumulator 12, and the contents of register C will be added to the contents of register D. After that means accumulator will get 15. After that this 15 will be temporarily stored in register D. When this instruction will be executed, then register B will be again decremented. Register B will get a 0, and after that contents of B will be moved to A. That means accumulator will get 0 this time. The instance accumulator gets a 0, 0 flag will be set. After that when this instruction will be executed, it won't jump to ABC because this time there's a 0 and it says jump only if the zero flag is not set. But this time zero flag is set because accumulator had got 0 in the previous instruction. That means program will stop here. That means the result will be in D. The final result 15, 3 multiplied by 5, 15 in decimal will be in register D. In hexa it will be equivalent to F. So I think that's it. There are many more programs. This was only to show how you can use these instructions and jumps to write a simple program like multiplication using repeated addition. There are many more programs you can yourself practice. Many examples in your book. So you need to practice those examples, those problems to get a hold of this machine language programming. We may be actually repeating this programming practice in microcontrollers in our second unit. So there we may be in fact discussing these instructions in bit more detail, and we will be doing many more examples. But for now I think this it here we complete our unit number 1. In next lecture we'll be starting from unit 2.